Okay, hi everyone, welcome back to my YouTube channel. Today we'll be solving LeetCode 125 valid palindrome. So my last video I dropped was on LeetCode 48, which is rotate image. I will put the link in the video or in the description box. You can go back, you can watch the video, share with your friends, like, subscribe guys. We'll be dropping out content like this at least once in a week. So let's dive into valid palindrome. Remember we said we'll be solving what, why and how for each question to give us a more rounded knowledge on what it is we are learning. So let's dive in. Valid palindrome 125, right? This is an easy question, like I've said. So a phrase is a palindrome if, after converting all uppercase letters into lowercase letters and removing all non-alphanumeric, right? So we're converting all uppercase letters to lowercase letters, which is one thing, by removing all non-alphanumeric characters. Alphanumeric characters just mean alphabet and numbers, right? So it falls down between lowercase A to Z, uppercase and 0 to 9. It reads the same forward and backward. So an example is probably we have madam, we have race, car, right? So these are most common palindromes we know of. Madam, when you start from the left, it spells M-A-D-A-M. When you also start from the right, it spells M-A-D-A-M, which is the same thing. So that makes it a valid palindrome. Also race car. So yeah, alphanumeric characters include letters and numbers, which I think I've explained. So given a string S, so you'll be given a string, probably like race car, madam, this is an input of a string. It will return true if it is a palindrome or false otherwise. So we are returning a boolean. We are either returning true or false. If you return true, it means it's a palindrome. If you return false, it means it isn't. So yeah, so this is an example. I know I'll give you 5-letter words. However, I think we'll be giving sentences, so you can see this is very long. So a man, comma, a plant, comma, a canal, colon, Panama. So you can see that all the non-alphanumeric characters were removed, all the upper cases were converted to lower cases, and then you can check if it's a palindrome or not, right? So it's very key you try to do those manipulations of strings. So also this race a car. So yeah, then we have this example, which is an empty string. S is an empty string after removing all non-alphanumeric characters. Since an empty string reads the same forward and backward, it is a palindrome. So yeah, that's clear. So for the constraints, we have the length of S will range from 1 to 2 times 10 raised to the power 5, right? S is ranging from 1 down to 20,000. S consists of printable ASCII characters. So those are how the characters can get in your computer, right? So you're ranging from A to Z, 1 to 2, and all the special characters also. So yeah, that's the words. So for the why, so like I did in the last video, I'll actually put a link of this also in the description box. You can come to this article and read whenever you're having a little bit of confusion, or if you don't feel you can watch the video. So understanding how to determine a valid palindrome is important because it enhances problem solving skills, particularly in string manipulation, right? We'll be converting uppercases to lower cases, we'll be removing non-alphanumeric characters. Yeah, and these are all string manipulations, which are crucial aspect of coding interviews and which you use in your code daily. You use it to do many things. Can it generate initials, right, of names and other things. So this also teaches algorithmic optimizations, right, especially the two-pointer approach. So later on you get to see how we use two-pointer approach to solve this particular problem, and it will show you how efficient it is and why you need it. Probably I'll make another video explaining the two-pointer approach in details. However, in this video we'll just go into how to do it and what it benefits. So yeah, beyond algorithmic learning, palindrome detection has practical applications. In form validation, a palindrome input might be required for a specific use case. In games, users may need to identify palindromic words as part of a challenge. If you are trying to teach people about palindromes and you are creating a game, something users might connect to, you can either ask them to put in a palindrome, which you have to validate using form validation. If, however, they are picking the words instead of inputting, you will also be validating it in a game scenario, right? It will be like part of a challenge. So most importantly, in bioinformatics, palindromic DNA sequences play a significant role. In molecular biology, palindromic sequences in DNA often serve as binding sites for restriction enzymes. So what restriction enzymes do is they go through your DNA searching for palindromic sequences. and when they get that, they get to clip it. This particular DNA can be separated from others. Scientists use it, so you can see these enzymes recognize specific palindromic sequences, like I said, and cut the DNA at or near this site, facilitating key processes in genetic engineering and molecular biology techniques. So yeah, so they use this to work on your DNA and to do genetic engineering and other things. So yeah, this one specific use case of palindromic sequences. So down to the main thing, we have how. So there are several ways to solve this problem, right? Well, we're going to focus on just two for now. We'll focus on basic approach, very simple approach, and an optimized approach. So for a simple approach, all you are doing is you have your string, you remove non-alphanumeric characters from the string, convert to lowercase, and you reverse the string. Then you compare the original string with the reverse string. So let me write it. So we have the simple approach. Now what we are doing is we are removing non-alphanumeric characters from the string. Right, and we'll convert. Okay, this is 1. So after we remove the non-alphanumeric characters from the string, what we're doing next is we will convert it to lowercase, convert the string to lowercase. Okay, I think we're removing non-alphanumeric characters and we're converting to lowercase. After this, we reverse the string. Then you compare the reversed string with the initial string. So that is, you compare the string you get at line 2 at this 2 with the one you are getting at this one, and return. Right, this is a simple approach. So yeah, so given the string of s, what you first do is, depending on the language you're using, right, as you know I'm using Java, I think what I'll do is I'll have a GitHub repo where I'll be posting the solutions, and in each of the folders, right, you have the solution. So I might actually extend the solution to include JavaScript and Python. So I have 3 main languages: Java, JavaScript, and Python. Why? Because I think we have many people using JavaScript and Python, so it's actually important for them to see the solution. But understanding what I'm doing will actually help you. So you can actually go ahead and try implementing your own, use your own programming language. So for the first one, we'll do s.replace all. So we'll be using a regex, a caret symbol, which is a negation. We'll have a to z, we have lowercase a to z, we have uppercase a to z, and we have digits 0 to 9, right? So what we are doing is we are picking everything that is not this and we're replacing it with this, right? So we are removing all non-alphanumeric characters. When you do that, you convert to lowercase, right? So we have done line 1. Okay, what is next? So we reverse the string. So we create a new string, we call it reverse. We use a new string builder. Then we reverse and we take the string. I mean, other programming languages, this one will be pretty straightforward. So after that, what we're doing is we're comparing both of them. So we've done reverse that equals s. So this is the reverse string, this is our original string, after removing all the non-alphanumeric characters and converting to lowercase. So yeah, so let's run this. Okay, so this was good. So let me submit. Okay, so you can see this is 15 milliseconds, between 2.57%, this memory. Okay, this is good, this is good, this is good. So this is good for a simple solution. So what we're doing next is the optimized solution, which is 2-pointer. So let me take this. Okay, let me edit this. Let me comment this out so it will be like we're starting afresh. Let's call this 2-pointer approach. So yeah, 2-pointer approach. So the most important thing here is to understand how a 2-pointer approach works. Like I said, I'll be explaining just the basics so you understand what's happening on a 2-pointer, right? So let's assume you are running a normal for loop. So what you do is you loop through I equals to 0, I less than, let me say s dot length, and I plus plus, right? So this is your normal for loop. You're only using I as your pointer. What it means is, let's assume you have an array 1, 2, 3, 4, 5, 6, right? You'll be looping from I, you take 1 as an instance, you go to 2, you go to 3, you go to 4, you go to 5, and you go to 6. And this is a one pointer approach. Let me put this here. This is one pointer approach. So what it means is you are only tracking one particular value at a time. However, in the two-pointer approach, you'll be tracking two values at a time. So what it means is, okay, for one pointer, right, so you can either track from I equals to 0 down to I less than s dot length, or you start from this end coming to this right. So you can start from the left, which is 1, 2, 3, 4, 5, 6, or you start from the right, which is 6, 5, 4, 3, 2, 1. Now those are the two normal ways we are used to tracking for loop, right? Now for the two-pointer approach, you combine both of them. So let me put this. So this is I equals to s dot length minus 1. I will be greater than 0, right? I minus minus. This is also one pointer. So what this means, this will start from the end. So you start from 5, from 6, which will reduce down to this one. So for the two-pointer approach, let's assume this is A. This is B. So for C, which is a two-pointer approach, you will be joining A and B. So let me explain. So what it means is you'll be keeping track of two variables at a time, or two pointers rather, since we're using pointers. You'll be keeping track of two pointers at a time. So you'll be keeping track of this and this. So you have the left pointer and the right pointer. So instead of just looping for this, you also be looping for the last one. So you take 1 and 6, you perform whatever you need to do. On your next iteration, you increment the left by 1, so you shift right, you take 2, you decrement the right by 1 also, so you take 2 and 5. For the next round, you will increment your left by 1, so you move from 2 to 3. For your right, you decrement by 1, so you move from 5 to 4. So for your left pointers, you have 1, 2, 3. For your right pointers, you have 6, 5, and 4. So you can see this has reduced the time we used to loop by 2, right, which is a very important thing. So imagine you are performing a sum operation, and instead of just doing for loop, you add 1, 1, 1. You can just do this, then track 2 pointers. For first index, you add 1 and 6. Second one, you add 2 and 5. You add 3 and 4. So this has optimized our time by half. So this is the basics of two-pointer approach. So you can use it in, depending on your use case, it might work. So this is just the basic, right? For your normal looping, you're using one pointer, you're tracking one thing. In this, you're having two things, your left pointer and your right pointer, and you're tracking them. You're incrementing left by 1, you're decrementing right by 1 until they meet. That's until you get to the center. So you are dividing your workload by 2. Okay, so that's one. So that's the basics of a two-pointer approach. If this wasn't really to be clear for you, you can pause, go back and rewatch it, or better still, try putting it down in writing, right, explaining it to yourself and see that you did understand. That will actually make things clearer. Okay, so what next? Okay, so we have to explain the solving using two-pointer approach, right? So let me say this is pseudocode. So the first is you loop through the string. Obviously using two pointers, that is assigning using left and right pointers, right? After that, when you loop through, you want to skip non-alphanumeric characters, right? In the simple approach, we're removing non-alphanumeric characters and converting to lower cases. But in this, all you are doing is just skipping. You skip the non-alphanumeric characters. After that, you compare the characters at the pointers. Right, so this is if they are not equal, return false. you return true. So when I return true, it means everything is actually equal. Right? So let's put this down in code. Like I said, I have the JavaScript and the Python solution, and I'll put the link in the description box. You can either check the description or the description of the playlist for you to get the link of the GitHub. What next are we doing? Okay, so this return. So, okay, so let's start with this. So let's do int left, starting from 0, obviously, and to right. So this should be s dot length minus 1, because obviously it's an array and it starts from 0, so the last element will be the length minus 1. While left is less than right. Remember, we are looping onto the middle, so while left less than right. Okay, so we have done the first one. The second one, we are skipping none of our numeric characters, so we have while left and right, and so this is where we check for non-alphanumeric characters, and in Java we use character that is letter or digit. So character is letter or digit. We do s dot char character at left. Okay, so this is left plus. So this checks if at any position of left we have a non-alphanumeric character, then we skip. So we do the same thing for right also. While left is on right and character is letter or digit, is that character at right. So we do right minus minus. So for the left we're incrementing, for the right we're decrementing. So after that, all we did do is compare the characters. So if character to lowercase of s dot char character at left, and if it's not equal to this character, what did I spell it? Character, this character, lowercase s dot char at right. So if the character at left and the character at right are not equal, you return false. Okay, after that you increment left, you increment right. After that, what you do is return true. Let me take this back a little. So this is it. So let's run and see. Okay, so this is good. So we submit. So remember this 15 milliseconds, 23, 57. And now you can see this running in 2 milliseconds. We have 99.13%. It beats 99%. So this is way faster than what we had before. So you can either use this or this, whichever one you choose to use. I think it's important you learn both of them. So this rounds up everything we're supposed to do on valid palindrome. Like I said, it's an easy question, so it's pretty straightforward. Let me know if there are any hookups you have along the way, if you need clarification on anything else, and let me know which questions you might want us to solve next. Yeah, what else? So it is really important for you to practice to your own self, right? Especially if you are not using Java, if you are using either JavaScript or Python. You can practice by yourself, then you can compare the solution I have on my GitHub to see whether you are good or you aren't good. I mean, you can still run and submit to know how good it is. So yeah, thank you very much, guys. Like, subscribe, share the video, comment, interact, and I hope you gain as much as you need to from this video. Thank you. See you next time.